Good morning. Now we are discussing about the phase shift oscillator. The circuit diagram of phase shift oscillator using this op-amp is shown over here. Instead of feedback resistor alone, we now make use of a potentiometer such that it can be adjusted to get a perfect distortionless output. This feedback network consists of 3 RC sections such that each RC section produces a phase shift of 60 degrees. As we have 3 RC sections, as a whole it produces a phase shift of 180 degrees, and this feedback is applied to the inverting terminal. Since the inverting terminal itself produces a phase shift of 180 degree, and hence the total phase shift produced by this phase shift oscillator will be either 360 or that will be nothing but equal to 0 degree. Hence the feedback is said to be positive. And this condition is satisfied at a particular frequency called frequency of oscillation. And this is the separate view of this feedback network consisting of identical capacitors and identical resistors. And here the capacitors and resistors are of different values. Now, for the oscillations to be maintained, the condition is the loop gain should be equal to 1. In order to begin the oscillations, loop gain should be larger than 1. The reactance of the capacitor is given by the expression minus Jx. Minus Jx gives the reactance of these capacitors. Let us apply Kirchhoff's voltage law to all these 3 loops. Applying it to the first loop, we get V0 is equal to I1R minus Jx. I1 into R minus Jx minus I2R. I2 is flowing in the opposite direction. I1 is in this direction, I1 is in this direction, I2 is in the opposite direction, therefore minus I2R. Similarly, applying it to the second loop, it is 0, there is no voltage, 0 equals I2 into R plus R, that is 2R, minus Jx. Next, minus I1R. Similarly, minus I3R. This is the direction of I2 and this is the direction of I3. Therefore, minus I3R again. Similarly, applying it to the third loop, we get I3R, I3 into R minus Jx, I3 into R plus R, that is 2R minus Jx, minus of I2R. This is equation 3. And the input to the amplifier is Vf is equal to I3 into R, where therefore I3 will become equal to Vf by R. I3 will be Vf by R. Now, making use of these 4 relations, let us simplify in order to get this final expression. So from first expression, from equation 1, I1 is V0. So here is equation 1, you can see at the bottom in red color, this is equation 1. So rewriting equation 1, right, we get I1 equals V0 plus I2R divided by R minus Jx. This is equation 1. Similarly, equation 3 implies I2 equals Vf by R square into 2R minus Jx. Right? Similarly, equation 2 implies Vf by R square into 2R minus Jx whole square minus V0 plus I2R whole divided by R minus Jx into R minus Vf by R into R. Solving these equations, solving these three equations, we get Vf by V0 equals R cube whole divided by R cube minus 6jx R square minus 5x square R plus jx cube. We call this is equation 4. If the phase shift between Vf and V0, the feedback voltage and the output voltage is to be 180 degree, right? Then in equation 4, the sum of j terms should become equal to 0. The sum of j terms in the denominator of equation 4 should become equal to 0 in order to have a phase difference of 180 degree between Vf and V0, between the feedback and the output. Therefore, we get minus 6jx r square plus jx cube equals 0, or simply minus 6 r square plus x square is equal to 0, or x is equal to square root of 6r. Reactance of the capacitor, we know that is minus jx, or this can be written as minus j divided by omega c. X is nothing but 1 by omega c, or x is equal to 1 by omega c, but omega equals therefore 2 pi f, that is equal to 1 by xc, or f is equal to 1 by 2 pi into xc, but x is equal to root 6 into r. Therefore, f is equal to 1 by 2 root 6 pi rc. Simplifying this, we get f is equal to 0.065 divided by rc. If C1 equals C2 equals C3 equals C, identical capacitors, and R1 equals R2 equals R3 equals R, identical resistors, the value of attenuation, otherwise known as feedback fraction, of the phase shift oscillator is beta equals 1 by 29, that will be equal to Ri by Rf. Therefore, Rf is equal to 29 Rf. The advantages of this phase shift oscillator is it provides good frequency stability. The stability of the output voltage is very good in case of phase shift oscillator. And this phase shift oscillator produces low frequency signals. The frequency of the output signals is very low, and it will be in the audio frequency range. The disadvantages of this phase shift oscillator are the circuit cannot be easily adjusted over large frequency range, since it has the ability to produce low frequency signals only. And since feedback is small, it is not easy to start the oscillations. It is a little bit difficult to start the oscillations because of small feedback. And the magnitude of the output is also small in case of phase shift oscillator. So this is about the phase shift oscillator. Thank you.